Let's look at another example of a one mean Z test. CNN Money reports that the mean cost of a speeding ticket, including court fees, was $150 in 2002. A local police department claims that this amount has increased. To test their claim, they collect data from a simple random sample of 160 drivers who have been fined for a speeding ticket in the last year and find that they paid a mean of $154 per ticket. Assume that the population standard deviation is 17.54. Is there sufficient evidence to support the police department's claim at the alpha equals 0.01 significance level? You may assume that the data is normally distributed. So I'd like for you to give this one a try on your own. Go ahead and pause the video and see how you do working through it. All right, let's take a look at this together. So our P is our parameter statement. So what they're asking us to do, they're asking us to test the police department's claim. So we have to go back and look for what their claim is. And they claim that the amount has increased from $150. So I'm going to test the claim. Mean speeding ticket costs 150 plus. See, I didn't even spell ticket right on here. It's just a quick note to keep you on track and keep you moving quickly through the problems is all that you need to write down for P. H is our hypothesis. So our null hypothesis is mu is $150. And our alternative hypothesis is that mu is greater than $150. We have three assumptions and conditions to check. So the random sample was stated, so we can check that off. It does tell us that you may assume the data is normally distributed, so you can do that and put stated. You could also use large here since the sample size is 160, so either one of those would work. Our population standard deviation is given as sigma equals 17.54. And because we're using the standard deviation that comes from our population, this is going to be a one mean Z as in zebra test. And then I'm going to plug everything in and calculate my test statistics. So 154 minus 150 over 17.54 divided by the square root of 160. So I get a test statistic of about 2.88. And with that is a p-value of 0.0019. So we're talking about less than 1%. And up until now, we've been using a 5% alpha, but this problem directs us to use a 1% alpha. So you should always use what the problem states. If the problem doesn't give you an alpha, then you should default to that 5%. So this one states to use a 1%, so that's what we're using. Our p-value is smaller, so we do reject the null hypothesis. So my conclusion statement, with a p-value of 0.0019 at the 1% significance level, we do have sufficient evidence the mean speeding ticket cost is more than $150.